Hi everyone. In this given problem statement of sort list, given the head of a linked list, return the list after sorting it in ascending order. So there could be multiple ways of doing it. One is that you can create a fresh linked list and keep on adding the values there, but it is going to increase the memory. In order to do it in the same list that we are operating, right? And instead of not creating additional memory storage, we can use divide and conquer. So the basic thing is out here, let's say take us example of 4 2 1 3. Okay, so here, right, we are going to divide this list into two parts. Then if I will again subdivide into, let's say, 4 and 2. So 4 and 2 would be subdivided, then here the sorted value would be 2 and 4, and this on the right hand side I'm going to divide it to 1 and 3, and after merging both of them it would be 1 3. Then I need to merge both of them, so the value would be 1 2 3 and 4. So how it's work, right? So now let us understand, right, where to make the divide. So for that, right, in a linked list, to make the divide or to find the middle element, we can use the concept of fast and slow pointer. So the basic idea is that we are going to create a slow pointer and a fast pointer. So fast pointer is going to go two step and slow pointer is going to go to one step. So after one iteration, right, the fast pointer would be at this position and the slow would be at 4. So now after the second iteration, right, the slow pointer would be reaching the end and it will only reach this position. So we can say, right, we can divide it to this area. So this would be the split, we can say, even though it's not properly appropriate, but still it will be same. So let's say if it's divided out here, so that is also fine. So once we create the divide, right, so the value would be 4 2 and 1 3. These are the two list. Again we are going to use slow and fast. So fast is going to reach at one step to the last one and slow would be still here. So we are going to make the divide, and once that is done, right, I can say, so these are going to get divided. So once they cannot be further divided, we can perform the merge, and the merge would, as I told you, right, would create 2 4, and on the right hand side it is going to create 1 3, and at last after again merging it up we are going to get this value, and this is going to take time of big O of n log n. So that's the idea. Now the how to understand how the slow and this split is working, right? So here, right, I can say def split, and here I can pass in the head, and here I can say slow and fast. So slow would be head dot next, and fast would be head dot next dot next. Now I can say while head and head dot next. So either if head is null or head dot next is null, right, then I can stop the loop, and out here I can simply say slow equal to slow dot next and fast equal to fast dot next dot next, because it is going to go two steps. And at last, right, when it is at this position, we can say return slow pointer. So this function is going to get called by, let's say, to get the mid, right? So I can say split, and I can pass in head. So whatever we got right, so I can say right head equal to mid, and to make this split right, mid dot next. And to make this split right, because it's an, after all, it's an linked list, right? So you have to make something null to split it. So mid dot next equal to null, and there would be two pointers like left list, and here, right, it is going to call that function. So with, let's say, short list, it is going to pass in the head. So once I say head, right, it is going to, let's say, the values are 4 2 1 3. Okay, so here, right, once I call head, right, so it will go from 4 to 2, and right list would be short list, and it is going to call right head. So that is the basic idea or fundamentals out here. And after that, right, it'll keep on dividing until we get a one value. So once, or we got single list, once that is done, right, with the help of recursion, I can say at last uh, merge list, and here I can say left list and right list. Once that is done, right, here I have to create a function of merging. So merging function, how it is going to work, it is pretty simple. If I say, so def merge list left and right, so here I can say while left and right exist, right, then I can compare the value. If left dot val is less than right dot value, so in that case, what I can say, and here I have to create a fresh list. So dummy equal to list node, and I can say cur equal to dummy, and here I can say cur dot next equal to uh, L, and then I can say L dot L equal to L dot next, and similarly, right, I can say else it would be cur, means if R is lesser, right, so it will be added. So cur dot next would be R, and R dot R equal to R dot next, and we also have to keep on incrementing our cur. So cur equal to cur dot next, and at last I can say return dummy dot next. Although it's not very clear, right, because here I've added too many things. Let us create the Python function or Python code where we can understand this concept into detail. Here, right, let us take the base condition. So if head or head dot next, or I can say and, so if not head, so I'm going to reach the end of it, and not head dot next, I can say return head. Else I can create a function called find middle, and here I can pass in the head. And here we are going to use the concept of slow and fast pointers. Slow and fast equal to head dot next and head dot next. And here I can add few more things. So I can say while fast and fast dot next, because I know, right, the fast is always going to reach faster. So slow equal to slow dot next and fast equal to fast dot next, and I can return slow. So once that is done, right, I can call this one. So from mid equal to find middle, and here I can pass in my head, and then I can say head right is going to be mid dot next, and to split it, right, I can call uh, mid dot next to, let's say, none. Once that is done, right, I can get two values. So would be left sorted, I can say sort list, and I can pass in the head out here, and right sorted, I can say sort list, I can say right head or head right, and I can call in the def merge, and here I can pass in, let's say, L1 and L2 both list. So here the idea is I can say while L1 and L2 both of them should exist, if L1 dot val less than L2 dot val, in that case, oh, I forgot to initialize my new pointer or list linked list, so it will be say dummy equal to list node, and here I can say cur equal to dummy, and here I can call in cur dot next equal to L1, and L1 also I need to increment to go to the see the next value. So L1 dot next else cur dot next equal to L2, and L2 equal to L2 dot next, and at last we are going to say cur dot next. Now let's say, right, one value is already getting added, right, and the second list is still left, then in that case what we're going to do, so I can say cur dot next equal to L1 if L1 is present, else L2, and once all this is done, right, I can say return dummy dot next, and after everything, right, I have to return the merge, and I can pass in left sorted and right sorted. Let me run the code. Yeah, I forgot to do a small change because this is a class function, right? So I can say self dot sorted list and self dot sorted list. Let me run it back again. It says maximum recursion depth reached. Let me check if I've made any mistake. Yeah, if either of them is true, right, then it will be this value. So let me run it back again. Yeah, I made another mistake, right? Instead of starting it with head, it will be head and head dot next. So that is a small error. I made one more spelling error. So this is the idea, this is the entire code. Let me show it down and let me submit the code. As you could see, the code got submitted and it is biting 32. It can be optimized if we are using normal way of sorting, but because they are right, I wanted to use divide and conquer, so it will be different, but it's a pretty good solution, right? With the help of recursion, we can easily find the solution, and you have used divide and conquer, so that helped a bit. That's all for this video. See you in the next one.